Hey everyone, today we are going to solve the LeetCode question count negative numbers in a sorted matrix. So you are given m by n matrix grid which is sorted in non-increasing order both row-wise and column-wise. Return the number of negative numbers in grid. So let's see the example. So you are given this input array, output is 8 because there are 8 negative number in the matrix. Very simple reason. And let's see the example 2. So there is no negative number, so that's why output is 0. And then we have follow-up question. So could you find the order of n plus m solution, not n by m? So I think there are several ways to solve this question. One is like a brute force and visit each place and count a negative number. So very simple algorithm. And also we can use a binary search because each list is sorted. So that's why I think we can use a binary search. But in that case, I think time complexity is m log n. So in that case, we execute binary search 4 times. And yeah, there is a solution with the order of m plus n. So let me explain how to solve this question with m plus n. Okay, so before I start the explanation with order of n plus m, so let me quickly write down the program with the brute force way and with a binary search. So this is a brute force. So count equals 0 and start looping for row in grid. And then I use one more for loop element in row. And then so if element is less than 0, in the case add +1 to count and then return count. Yeah, that's it. Let me submit it. Yeah, looks good. And the time complexity of this solution should be order of m by n because we visit each place once, and the space is O1 constant time. So next I will show you how to write a code with a binary search. Okay, so let's write a code with a binary search. So count equals 0 and for row in grid, and then first of all initialize left and the right equal 0 and the length of row -1, and then while left is less than or equal right. In that case, calculate the middle position and left plus right and divide 2. And if row middle is less than 0, in that case, move right to mid -1. Else, left equal mid +1. And then after that, add count equal length of row minus left. So left position is like a first negative element in this case. So that's why just subtract left from like a whole length of row. And then after that, just return count. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of m log n. So in this case, we execute binary search m times length of row. So that's why. And the space complexity is O1. Okay, so next, so let me explain how to solve this question with order of m plus n. Okay, so let me explain with this example. So this matrix coming from example 1. So to solve this question, so first of all, we have to understand the matrix condition. So this matrix is sorted in non-increasing order, both row-wise and column-wise. So what does row-wise and column-wise mean? So look at the first row. So these numbers are sorted in non-decreasing order, right? 4, 3, 2, -1. And the second row is also like a 3, 2, 1, -1. And look at the first column. So this matrix is sorted in like a column direction, like a 4, 3, 1, -1. So look at the last column, like a -1, -1, -2, -3. So that means, so top left is like a highest number in matrix, and then from from left to right, so that means like from high to low, and then from top to bottom, so number is high to low. So this is a very important condition. So we use this condition to solve this question. So in this case, we start from top right corner here, because this column is a lowest number in each row, right? And then, so top right corner is a biggest number in last column, right? So that's why we start from here, and then if this number is negative, so in fact this is a -1, right? So that means, so rest of numbers in column A also negative, right? Because so this is the highest number in last column, so highest number is -1. That means rest of numbers are definitely negative, right? So in this case, if this number is negative, so we can add +4 to, let's say, count. So we find 4 negative number in one check. And then if we find a negative number, we move column, so that means this way. And then again, we check this number. So this number is positive. So if the number is positive, we go down the next row. So now we check here, and then, so this is a 1 positive number. So that's why we move down, and then we find a -1. That means rest of numbers are also negative. So that's why add +2 to count 6. So now we are here, and then in the case if we find a negative number, we move just left here, and then check this number. So this number is positive, so we move down, and then we find a negative number, so add +1 to count. So when we find a negative number, we move left, and then check this number, also -1, so add +1 to count, and then we move next, but this is out of bounds, so we finish like traversing. So that's why in this case output is 8. So by the way, we move like this and this and this. So time complexity of this solution should be order of m plus n, right? Because we traverse at most m row and n column once. So that means if we find a negative number, we move left and never go back to right side, like this position. And then if we go down and down, and we find a negative number, in that case we never go back to like a top side, like this. So that's why we traverse at most m row and n column once. So that's why in this case time complexity should be order of m plus n. Yeah, so that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, calculate the length of row and grid and columns. Length of grid 0, and count initialized with 0. So this is a return value. And first of all, start from like a top right corner of the matrix. So that means row position should be 0, and the column is equals -1. And start traversing while row less than rows, and the column is greater than or equal 0. In that case, we keep traversing. So if grid row and the column is less than 0. In the case, so rest of numbers in column ways are also negative. So that means count, so what number? So in this case, so rows minus current row. So this is a whole length of row, and then this is a current position. Just a simple calculation, and then add negative count, right? And then when we find the negative number, so we move left, so move column minus equal 1. If not the case, so that means we find a positive number. In that case, we move down, so that's why add +1 to row direction. Yeah, actually that's it. After that, just return count. Yeah, so let me submit it. Looks good. Very efficient algorithm, beat almost 95. So time complexity of this solution should be order of m plus n. So as I explained earlier, we traverse at most m rows and n columns once, so that's why. And the space complexity is order of 1 because we don't use the extra data structure, just a simple variables, so that's why. Yeah, and I added a comment in the code, so you can use these comments as a review later. Yeah, so that's all I have for you today. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question.